Hello, and welcome to I Know Dino, the Big Dinosaur Podcast, where we cover news, interviews, and discussions of all things dinosaur.
Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And today we'll be talking about Falcarius, as well as a bunch of dinosaur news. So first in the news comes a PLOS Paleo blog article about dinosaurs from 2015, written by Andrew Fark, who was an editor for PLOS One and Pure J. He lists all 35 dinosaurs that were discovered in 2015, most of which we covered on this show, but there were obviously some that we didn't cover. And we'll put a link in our email newsletter as well as post it on our blog if you want to check them out. So 35 dinosaurs is obviously a pretty huge number, and another reason I'm really excited about this year. He also compares the number of dinosaur discoveries that were published in free-to-read journals versus paid or behind paywall journals, and this is the first year that a majority of them, about 51% of them actually, were in free-to-read journals. So that's a really good step. And it's really awesome that these are published in these open access journals because it allows people like us and you, our listeners, to casually read the articles or at least view the awesome images and diagrams that they have. And as we point out all the time, there are things that are often misreported by mass media since they don't always have a good grasp of paleontology. So it's great to be able to read the real story and see what the scientists actually said and the terminology that they used. And I often learn a few new words or concepts that I wouldn't have found out about otherwise. And those rarely make it into the summarized article that you'll get in a mass media outlet. Since more and more of these dinosaur discoveries are being published in open access journals, Sabrina and I are going to be changing our Patreon goals to be more exciting and meaningful to all of you listeners. The previous goal we had at $100 was to get access to paid journals. But since more and more of these dinosaur discoveries and other dinosaur news is showing up in open access journals, and then we can find reference to what is described in other places, it's probably not worth spending a bunch of money on.
Yeah, so now our new goal is called Share the Wealth, and if we make it to $200 a month, we want to celebrate, and we want to send all our patrons an awesome sticker version of our logo. We've also kind of generally revamped our Patreon page, so if you want to check out our new description, we thought it could use a bit of a more personal touch. In the future, we plan to do a listener survey. We want to know what you guys think and what kind of rewards you're looking for, because we can't do this without you, and we're really grateful for your support, so we want to make sure we're giving back in a way that's meaningful to you.
Yeah, so if you want to support us, you can go to patreon.com/iknowdino, and you can become a patron at many different levels. They're all described in there and what the different benefits are. Next in the news is an article published in the journal PLOS One, which is one of those open access journals we were just talking about, titled A New Leptoceratopsid with a Unique Ischium from the Upper Cretaceous of Shandong Province, China. It was written by Yimeng He and others. What they found was part of a Leptoceratopsid, and that's the group that includes Protoceratops you might be familiar with. And this dinosaur that they have named Ischioceratops juchengensis. Ischioceratops comes from ischium, which is a bone in the hips, and ceratops being horn face like all the other ceratopsians, and the species name is derived from Jucheng, which is where the fossil was found. So Jucheng is in the Shandong province of eastern China, and is located in between Shanghai and Beijing, obviously on the eastern part of China like I mentioned. Ischioceratops is the second leptoceratopsid dinosaur from the area, which has already been the site of many other dinosaurs' discoveries. So it's becoming quite a dinosaur area over there. Ischia in dinosaurs are the parts of the hip structure which typically point towards the tail, and in this case the ischium is still situated in a pretty typical way, but the bone itself is very unusual, and that's why they decided to name it after the ischium. They say that the bone itself looks like a recurved bow with a bulge in the middle, and if you're wondering what a recurved bow is, like I was when I read that, it's one of those archer bows where the ends straighten out or curve away from the archer a little bit on just the tips, so it kind of has a big curve to it, and then the ends are just a little bit flat. And that's pretty much exactly what the dinosaur bone does look like, along with that big bulge in the middle. It's pretty interesting looking. So they write a lot about the bulge in the ischium, which contains several holes in it, and they call it, quote, unlike that of any other dinosaur, end quote, which is why they think it was so important to mention in the dinosaur genus name. So my first question was if that big bulge and the perforations in it could be the result of disease or another injury, because we've discussed that in the past, and it's obviously the type of thing that you might expect from a disease or an injury as holes or otherwise abnormal shape. But they believe that the fact that both ischia, there's actually a pair of them, have symmetric expansions and openings, and they appear to have neat edges, means that it was a normal condition and not some sort of growth or pathology. They also found many vertebrae, tendons, and leg bones, and basically what they ended up finding was from partway down the shin, up through the hips, and then down part of the tail. So, of course, that means that they didn't find the skull, and they point out that most ceratopsians are described primarily based on their horns and their mouths. And since they didn't find the skull, it makes it kind of hard to identify and compare with other ceratopsians. But they think that the ischium is so unique that it warrants its own genera. I hope that in the future they manage to find that all-important skull so that we can see that it is in fact its own dinosaur, or maybe that it isn't, and it's just a ceratopsian where we hadn't seen the ischium before. I feel like that could happen. But we'll have to see. Next to the news is a really fun article that was published in the PureJ preprints, so it hasn't been peer-reviewed yet, and it's titled Connect-Controlled Dinosaur Simulations for Education and Public Outreach. It was written by William Sellers and Stuart Pond. The authors say that they had noticed an increasing public interest in dinosaurs, and that could be useful to generate interest in science and technology. And, quote, with increasing popularity of dinosaur films that claim to portray realistic dinosaur behavior, one question that is regularly posed for paleontologists to answer is how we know that the reconstructions are accurate, end quote. They specifically took a look at dinosaur locomotion through multi-body dynamic simulation, or MBDA, through musculoskeletal computer models. It's pretty similar to the concepts we discussed in episode 51 when talking about how far T-Rex and Allosaurus could open their mouths. But the really fun part they added was a Microsoft Kinect interface to control the dinosaurs. So if you're not familiar, you probably are, but just in case, the Kinect is basically a pair of cameras, and one is basically a standard camera, while the other senses depth and infrared, and it hooks up to either an Xbox game system or a computer, and you move around a room, and then the Kinect can figure out where you are and how you're moving. So it can either emulate dance moves or sports actions or whatever kind of game you're playing. It can figure out what you're doing, and then you don't have to use a controller. They hooked it up to a computer along with their models of a Tyrannosaurus, a Triceratops, a Brachiosaurus, an Edmontonia, which is an ankylosaurid, an Edmontosaurus, which is a hadrosaurid, and a Gorgosaurus, which is a tyrannosaurid about the size of an Allosaurus. They took it to the 2015 Cheltenham Science Festival for their first use with the public, and they found that the bipedal dinosaurs were easy for everyone to control, but the quadrupedal models were difficult to control and probably need some work. So Shana Montanari on Forbes added in her article that the technology uses, quote, dinosaur movement based on physical laws of force, gravity, and friction. Users quickly learn that they can't get a dinosaur weighing upwards of 9 tons to move about in a nimble way, end quote. And I think that's what they were saying about the quadrupedal ones being a little more difficult to move. If it's expecting you to move like you weigh 9 tons and you have 4 limbs, it's obviously not very intuitive for humans. They posted all their software and 3D models online, and they invite people to download them in the hopes that others will, quote, find further uses in areas such as 3D printing for anatomical education and virtual world simulations, end quote. I think that's pretty exciting. I know that I would love to 3D print one of these dinosaurs, and it would be fun to mess with simulations. And if I had a Kinect, maybe I would try to download their software and pretend to be a dinosaur on the screen. It could be pretty fun. Next in the news is an article published in the Journal of Zoology a couple of months ago titled Opisthontonic Head Displacement in the Domestic Chicken and Its Bearing on the quote-unquote dead bird posture of non-avialan dinosaurs. And opisthontonic just references bending your back backwards. If you've ever done yoga, it's like that bow move, or if you're trying to look at someone behind you without turning around, it would be like arching your back that way. It's called opisthontonic. It was written by A.P. Russell and A.D. Bentley, and if you're wondering what the dead bird posture is, the easiest way I can describe it is if you remember the early scene in Jurassic Park where Dr. Alan Grant is imaging an underground dinosaur, and this picture comes up on a TV of a quote-unquote velociraptor fossil, and it's kind of in this curved shape where its back is all arched and its head is sticking backwards too.
Very uncomfortable looking.
Yeah. If you haven't seen it, it's basically like if you take the tail and the head and you tried to like smash it into a circle shape. It's a pretty unnatural position, obviously, compared with how they would have been positioned while living. So I'm not sure about the underground imaging technology, but the posture is very characteristic of dinosaur fossils. And I've always thought of it as fortunate, since a curled up dinosaur seems more likely to fossilize whole than a long stretched out fossil that might not all get buried. But these authors wanted to find out if they could duplicate the science behind the posture. So according to Brian Switek on National Geographic, there are two major theories of why they adopt this posture. One is that the pose is caused at the time of death by poisoning, lack of oxygen to the brain, or similar circumstances that cause the neck and tail to spasm into weird angles. And other paleontologists have suggested that the pose happens after death, with immersion in water or decay tensing muscles and ligaments that pull the head back and tail up, kind of like a rigor mortis type thing. The phenomenon in non-avian dinosaurs is often seen with the tails and the necks, but since modern birds don't have long tails like dinosaurs, they used birds with long necks instead, specifically silkie chickens.
Silkie chickens?
Yeah. So I guess they're called silkie chickens because they're really soft and
shiny?
No, just soft. They feel like silk, apparently. They look kind of fuzzy. So the authors say, quote, "We purchased 15 whole plucked frozen silkie chickens from a local grocery store. After thawing, 5 were used to establish appropriate positioning and effective radiographic exposure patterns, and the remaining 10 were used for data gathering," end quote. So they just literally bought 15 frozen chickens and bent them around and took x-rays of them.
Silkie chickens, though.
Yeah, silkie chickens. It's an important distinction, because I think silkie chickens have a longer neck, or at least those are the ones they used for some reason. So they bent the neck back and forwards, and they said when it was bent forwards, it actually kind of sprang back to an S-shaped curve if they bent it past a certain position, which is closer to the position they would adopt while they were alive. And they didn't have that same problem when they were bending the neck backwards. Then they x-rayed the chicken in many positions to determine exactly how the vertebrae were aligned and the angles in between the vertebrae, because they thought that might be important in comparing to dinosaurs, because one of the few things you can tell about a fossilized dinosaur and its behavior and shape is the exact position it was fossilized in. We can make these accurate measurements of what the angle between the vertebrae was when it was fossilized, whereas you can't really do the same thing about what it looked like when it was alive. So they found that it was easier to bend the necks backwards and forwards, like I said. It hardly took any effort at all to bend the neck backwards. They didn't pose an explanation for how dinosaurs ended up being put in the position for fossilization, but they were happy to show that extant birds seem to have a similar ability to bend as the fossilized dinosaurs did. So they think that they've more or less proven that the dinosaurs could bend in that way while they were still alive, or at least they wouldn't have had to get smashed into that shape because it was pretty easy to bend. They would like future research to establish a link between the structure of chickens' vertebrae joints and their mobility so that we can better understand which dinosaurs would be capable of the posture. So it's kind of interesting. It's a little bit of a bummer that they don't have any idea of why they're doing this position, because that seems like the more interesting question, but it's always important to make sure that it's even something feasible. No one had really checked to see if those two hypotheses were even possible with it straining into that shape. Next in the news is an article that's on the New York Times titled Amateur Sleuths on the Dinosaur Trail. It talks about a specific group of people that are doing some excavation in Colorado in the U.S. So around the time that T-Rex Sioux was auctioned off for over $8 million, the Toadstool Geologic Park in Nebraska was noticing a lot of fossil thefts. So the Forest Service decided to start a preservation program. And they now employ 2 paleontologists in charge of the Forest Service's 193 million acres. And both of those paleontologists are assigned to the Rocky Mountain region, despite the fact that there are 350 archaeologists in the Forest Service. But that's a discussion for another day. Bruce Schumacher is one of those paleontologists, and he's the one who was interviewed in the article. Bruce says that the program is really more about education than commodities, like the rest of the mineral department that they're relegated to. And because of that, he leads a group of volunteers twice a year for 1 week at a time to excavate dinosaur fossils and footprints. The current site they're focusing on is called Picket Wire Canyon, and it's in Comanche National Grassland in the Morrison Formation in southern Colorado in the U.S. Recently, they uncovered a juvenile sauropod track that is next to an adult sauropod track that we already knew about, and they're using that as possible evidence that sauropods might have traveled as a family.
That's exciting.
Yeah, that's pretty cool. There are also theropod tracks in the area, possibly meaning that the sauropods were being hunted, and they haven't uncovered all the footprints in the area yet, so they don't know what else they might find.
Poor sauropod families.
Yeah, that's why they gotta travel in packs. Protect the little ones. There are lots of dinosaur fossils in a wall near the tracks, and they've been excavating those as well, including a 15% complete Camarasaurus that's already on display. Since they only go out twice a year and it's gotten so popular, they don't even advertise the program anymore. And Bruce says that most of the volunteers come back year after year, and they're mostly retired amateurs interested in paleontology. Sometimes they rebury their finds in order to prevent them from being stolen or damaged by erosion in between their expeditions. Bruce wants his style of program to be replicated in other parts of the country, and it definitely could be, especially since the National Paleontological Resources Preservation Act of 2009 was passed and is intended to prevent theft and collection of fossils from public lands, and they might add staff to help with the problem. So it's pretty interesting to me that there's such a huge area and only 2 people assigned to it. It makes me worry a little bit too, because I know that erosion can destroy some of these fossils. So if there's nobody looking at most of the area or nobody making sure that the fossils aren't disappearing, that could be a lot of lost discoveries.
Think of all the sauropod families we don't know about.
Yeah. And think of all the people who could be going on these digs if there were more programs.
Mm-hmm.
Next in the news is probably the most widely reported story since our last episode. It's an article titled Theropod Courtship, Large-Scale Physical Evidence of Display Arenas and Avian-like Scrape Ceremony Behavior by Cretaceous Dinosaurs. It was written by Martin Lockley and others.
I just want to quickly shout out to Chris from Twitter. Thanks for sharing us one of the links for his story.
So when modern birds are about to mate, they sometimes gather in a big group called a lek, and they make a bunch of scrapes as a show of establishing territory before breeding and also to impress mates. But the scrapes in question weren't surrounded by any fossilized eggs, so it's not really clear if the actual nesting site is adjacent to this mating display area. But the authors propose that the scrapes may be an alternative way to determine if a site was used as a nesting colony, so I guess they assume that if they're mating there, they're probably nesting nearby. So the primary site is in Rubidoux Creek in western Colorado, and we talk in depth about ichnology and the science of trace fossils in episode 2 with Dr. Anthony J. Martin. Ichnology is all about things that are left behind by dinosaurs that aren't their own bones, basically, or other parts of their body. So it could be tracks, it could be coprolite, it could be things like these scratch fossils, but they're all things that they either created or left an impression or a trace, thus the trace fossils in the world. So the authors define an ichnogenus to describe the finding of these scrape fossils, and they named it ostendoiknos, meaning to show or to display, and then a trace as the second part of the word, with the ichno species being bilobatus, meaning two lobes, referencing the marks that are made by separate feet and kind of having two parts to the scrape. So they say they are, quote, large scrapes up to 2 meters or about 6 feet in diameter, and they occur abundantly in several Cretaceous sites in Colorado, end quote. And they also say, quote, the largest site reveals about 60 scrapes on a single sandstone surface exposure up to 50 meters long and 15 meters wide, end quote, which is about 165 by 50 feet. And, quote, a second site with 8 well-preserved scrapes occurs on a single sandstone surface about 20 by 5 meters, end quote. And that's about 65 by 15 feet. So it's pretty impressive how many of these things were preserved. I guess if you're comparing it to something like a trackway, it wouldn't be that uncommon to have 60 footprints in a row. But compared to a lot of the things we talk about where we might only have just 1 or 2 bones and be defining a species based on it, it's pretty remarkable to me to have 60 individual kind of replicated scrapes in a single piece, meaning 60 of those individual holes that were kind of dug. So I think it's really cool that there are so many of these different fossils so we can really get a good statistical sampling rather than just having one individual thing where you don't even know if it's just a crazy dinosaur doing something weird. It looks like it's an actual behavioral pattern. They also say that, quote, the size, depth, and distribution of these scrapes is variable. However, most typically consist of parallel double troughs comprised of multiple scrapes separated by a raised central ridge. A few show complete outlines of 3-toed theropod tracks, and some show thin aprons of excavated sediment aligned with the long axis of scrapes. So basically like if you were digging and you were piling all the dirt up on one side rather than piling it up all the way around. They also point to 2 other sites, one each in eastern and western Colorado, where more of these fossils have been found. Quote, they constitute a previously unknown category of large dinosaurian trace fossil, inferred to fill gaps in our understanding of early phases in the breeding cycle of theropods, end quote. And they're found in a specific type of rock called Dakota sandstone, which the authors say hasn't yielded many body fossil remains, but they're great for fossil remains like tracks and these traces. It's especially interesting because this is the first physical evidence that dinosaurs behaved similarly to extant birds while mating. And it's really difficult to find this kind of thing because usually any sort of behavior doesn't fossilize very well outside of tracks and a couple other simple things. So it's pretty fascinating. I did wonder if there might have been another possible reason for these scrape markings, and when I first saw the article titles, I was pretty skeptical of it. But the authors do a really good job at describing why they believe so strongly that they are mating displays rather than just some other alternatives. And they talk specifically about 3 alternative theories that do seem like some of the more obvious ideas. So one of the alternative theories they talk about is that they might have been actual nest sites or nesting colonies, meaning maybe they dug these holes and that's where they kept their eggs, which wouldn't really be anything that remarkable. We've seen other nests before. They say that this is unlikely because they didn't find any indications of eggs or a nest rim. So like I was saying, they kind of dug a hole, but they piled all the dirt up on one side, and most nests that you see, they pile the dirt up around the edge of the nest to kind of protect them and prevent eggs from moving around too much. And there aren't any imprints of where eggs had been or any egg shells or anything like that. So that seems pretty unlikely that it was just a nest. Another possibility they looked at was, were the dinosaurs digging for something else, for instance, food or water or shelter? So they said if they were digging for water, you'd expect water to pool in the bottom of the hole that they dug. And if water pooled there, it would wipe out the traces of these claw marks that they saw. So that didn't seem very likely. They said that if they were digging for food, which may actually be a pretty good guess, since there has been evidence of a Deinonychosaurid with a claw that had gone through a burrow. But in these cases, there weren't any burrows found in the proximity. And since there were so many of them, if they were digging for food, you'd expect there to be at least some burrow or, tunnel or something where it looked like the dinosaurs had a reason to dig for food there. So that doesn't seem too likely. And as far as shelter goes, they don't believe it resembles a likely burrow structure, and they think that burrows are pretty rare for dinosaurs anyway, so the idea that there would be so many burrows in this one little area seems a little bit weird. Another possibility was that they were territory-making scrapes, and the main place we see this is with things like cats, both domestic cats and the big scary lions and stuff. When they mark their territory, they'll scratch and then they'll also mark it with urine at the same time. But the authors point out that birds are water conserving or urecothelic, and no animals in that group use scent to mark their territory. Plus, this area was likely too wet for marking territory to work well anyway, so that's probably not the cause. So after all that, they think that the most likely answer is that they were making these scratches to impress females. And in modern birds, we see these large groups of males competing for a female's attention in the activity, like I said, called lecking. And the size and shape of these holes that were dug are pretty similar to what you might expect if a dinosaur was going to do some lecking. So it makes a lot of sense that that's the most likely answer. They also said that while they were doing this lecking, they were probably also making a lot of noises and flapping their arms all over the place and doing stuff like that. But none of that fossilizes, so it's pretty cool that they found evidence of it through these scrape marks, because it's the only kind of thing that would fossilize out of the process.
One thing that comes to mind is the show Dinosaur, where Earl teaches his son Robbie the mating dance, and there's a lot of jumping around.
Yeah. That was the first thing I thought of too. And then I thought, are they just saying this because of the show Dinosaur? But then it looks like there's a lot of good science behind it. On a much simpler note, an article published on livescience.com titled Digging Up Dinosaurs, 5 Trends That Will Be Bigger Than T-Rex. Kind of a goofy title, but they're talking about things they expect to see in 2016. One of the things is, quote, fossils galore. And we definitely expect that too. Lots of new dinosaurs and probably a better understanding of fossils when they're re-examined. And sometimes they even find new species by re-examining fossils. They also talk about downloadable dinosaurs, meaning CT scanning and 3D printing and hopefully combining the two so that you could make your own little dinosaurs.
And that's already happening in some areas. Get to that in a minute.
And it also makes it easier to compare things when you can do 3D printing, which is basically the basis of taxonomy, where you're comparing your finding to a type species or another established specimen. And you used to have to go to a museum and compare it, was the most common way. Otherwise, you might be able to look at a really specific description of the bone where you could compare measurements. But if you could just 3D print an example of the bone right there in your lab, it would make it a lot easier to compare things. They also talk about legal responsibility, citing that Mongolia, China, and Brazil are now really focusing on preventing illegal trading of fossils from their countries and trying to track down some of these other fossils and get them back that we saw quite a bit of in 2015. They have one called, quote, screen fling. I'm not sure why they call it that, but they're talking about using computer modeling to determine how dinosaurs moved and use their senses. And we just talked about that earlier today with the dead bird posture and some of those gape angles and things like that. And finally, they talk about diversity in the field, referencing the fact that years ago, the norm was that archaeologists from the US and UK would go places and describe or take fossils without really any local scientists being interested in paleontology. But now there are huge paleontology communities starting to grow in Argentina, China, South Africa, and Kenya, as well as other parts around the world that in the not too distant past didn't really have much of an interest in paleontology, which is great. Next in the news, there's an article titled, Did Dakota Raptor Really Face Off Against Tyrannosaurus? And it's a blog entry by Brian Switek on National Geographic. We talked a lot about Dakota Raptor, and I think it's super awesome, and how maybe they could take down a Tyrannosaurus. And I really like this article because it brought up a couple possible reasons why maybe that didn't happen as much as everyone likes to imagine. This article is worth looking at, if for no other reason than there's a great picture of a nice feathery Dakota Raptor pulling feathers out of an ornithomimus at the top of the page, so it's a pretty fun picture. He points out that there isn't particularly strong evidence to show that any dromaeosaur is hunted in packs, and most of that evidence relies on them being found dead in groups, which could be attributed to many things, including fighting over something that is already dead. But it's kind of a controversial area. Some scientists think they most likely did hunt in packs, others think they didn't. But it's really difficult, like we were saying, to fossilize behavior like that. But if they didn't hunt in packs, it's unlikely that a Dakota Raptor would be taking down a full-size T-Rex, so it would have been limited to juvenile T-Rex and full-grown Dakota Raptor, most likely.
Yeah, and it's possible that even though they both lived in the Hell Creek Formation, they might have been in slightly different areas.
Yeah, and with that, they could be just in different niches within kind of the general area. So maybe T-Rex and Dakota Raptor were hunting different prey and had very little overlap, which would mean that they didn't really encounter each other very often. And it could account for the fact that Dakota Raptor hasn't fossilized in the Hell Creek Formation very often, since we've only found it once compared with about 50 skeletons of T-Rex. Another possibility is that Dakota Raptor just had a really small range within the Hell Creek Formation, and that's why there's only been one found versus all those T-Rex skeletons. But it's really hard to tell. There's a lot of things that affect fossilization, so they may have actually been all over the place, but for whatever reason they were less likely to fossilize, like they ate each other when they died, or T-Rex was fossilizing in certain areas for other behavioral reasons. It's really difficult to look at a paleontological record of fossilization and try to extrapolate how many of that species were around there, because that's generally not considered good science to base the number of actual animals that were around in the area on the number of fossils.
Yep. Now moving on to other types of news. Back in December, a father in the UK found out that his son had run up a £4,000 bill from buying upgrades to the Jurassic World Builder game on his dad's iPad. And for those who may not have played this builder game, there was also a Jurassic Park builder game, and basically you start off with a dinosaur, I believe it's Triceratops, and then you can level up your dinosaurs, and then you kind of do different tasks that take a long period of time to earn whatever money is in the game, and you can buy more dinosaurs or upgrade your dinosaurs, do all these things. And then, of course, it's a freemium game, so if you want to speed up the time and not wait, then you can purchase using real money these upgrades. But this kid had no idea that he was spending real money. He's only 7 years old.
And he didn't want to wait.
Of course not. And then his dad found out when his credit card was declined. And apparently the kid knew his dad's password. The dad was unaware of that. And the dad was understandably upset, and so he complained to Apple, who eventually gave him a refund. So that was lucky.
Yeah, it's kind of funny in all those stories, because there have been quite a few out of the US too. It seems like Apple pretty much always gives money back. Google does the same thing too.
In Queensland, Australia, Mayor Robert Lognan is in talks with the Queensland Museum to see if Roma, which is a town west of Brisbane, can house a 15-meter-long, 4-meter-tall 3D Rotosaurus dinosaur replica, and that would be life-size. And this is kind of going back to what Garrett was talking about, dinosaur research with 3D printing and CNC machines. So the replica would be built using a combination of a CNC machine and a 3D printer. It would be based on scans that hopefully the Queensland Museum can provide of Rotosaurus. It would take them about 2 years to build. The reason they want this is because Rotosaurus fossils were found just a little bit north of Roma in 1924, and they're actually the oldest dinosaur skeleton found in Australia. And so the town's hoping to boost tourism with their life-size replica.
Cool.
And just for a bit of fun, on New Year's Day in Grand Rapids, Michigan, specifically at the skating rink at Rosa Park Circle, somebody dressed up as a T-Rex and skated around. And there's a video, which we'll post on our blog, and this person looks very awkward and it looks very difficult, especially since they can't use their hands for balance. But considering all that, it's pretty impressive they can make it around the rink.
What kind of a T-Rex costume is it? Is it like one of those pajama ones or?
No, it's like full size.
Like 10 feet long kind of thing?
Something like that, yeah.
Wow.
Very large, and then they make sure to keep their hands in. It's just little T-Rex hands.
I can't even really ice skate just on my feet without a T-Rex costume.
Yeah. So pretty impressive. And lastly, Offbeat Home and Life shared and what I think is an exciting post this week about ways to decorate your home with cool dinosaur stuff. So some examples include dinosaur string lights, you string them up, kind of how you would decorate a college dorm. T-Rex cracker plate. We have something similar. It's a Brontosaurus cake platter. And dinosaur lamp bases, as well as dinosaur bookends. So lots of good decorating ideas. And that's it for the news. Now on to the dinosaur of the day, Falcarius, which was requested from Jillian via Patreon. So thank you, Jill. The name Falcarius means sickle cutter, and it's named for its sharp claws. It was a therizinosaurian dinosaur that lived in the early Cretaceous in Utah. Falcarius bones were first found in 1999 by Lawrence Walker, who was a commercial fossil collector. He worked on the black market, but more on that in a bit. He told the paleontologist James Kirkland about it, and in 2001, Kirkland and a team from the Utah Geological Survey helped uncover bones in Utah's Cedar mountain formation. And if the name James Kirkland sounds familiar, it's because we interviewed him and talked about his discovery of a Utah raptor. So back to Lawrence Walker, he sold fossils on the black market, but he thought that this Falcarius was an important find, so he came forward. And he ended up spending 5 months in jail and paid a $15,000 fine. And Kirkland said, quote, he may be the first person to ever go to jail for fossil theft on public land. Which is kind of interesting, thinking about what Garrett brought up earlier about Mongolia and a few other countries clamping down on fossils being taken from public lands.
Yeah.
There were 2 bone beds found of hundreds, maybe thousands of Falcarius individuals. So in 2006, they estimated there were at least 300 individuals. 2005, more than 2,000 specimens have been excavated. Many of them were disarticulated bones as well as juveniles. In the beginning of 2010, there were over 2,700 individuals found, and by the end of 2010, over 3,000 specimens found. A second site was found in 2008 in Suarez Quarry with many adults and possibly a slightly different type of Falcarius. Both of these graveyard sites may have been associated with a spring, the reason that there were so many individuals found there, so they may have died due to drought or toxic gases or bacteria, and it's possible they all just came together at those springs at least periodically. Because there's so many individuals of different sizes and ages, it would be great for research and finding out how fast Falcarius grew, when they matured, and even how much variation was between them. Kind of reminds me of the Maiasaura find in Montana, and Jack Horner and all the people who are researching that, and they're able to cut open the bones and learn a lot about that particular dinosaur.
Yeah, it helps to have a good sample size.
Mm-hmm. Falcarius was first described in 2004, but it wasn't formally named until May of 2005. Co-authors, including Scott Sampson and Lindsay Zano, but not Jim Kirkland, who was also a co-author, said that Falcarius, quote, is the missing link between predatory dinosaurs and bizarre plant-eating therizinosaurs. And Lindsay Zano also said Falcarius is, quote, the ultimate in bizarre, a cross between an ostrich, a gorilla, and Edward Scissorhands, so you can imagine. The type species is Falcarius utahensis, so obviously named after Utah, where it was found. And Falcarius helps to show the early evolution of Therizinosauria, which is its group, and their relationship to other theropods. Falcarius shows a transition between older theropods and Therizinosauridae. And it shows the change from a meat eater to a plant eater. Some scientists think that it may have been an omnivore. It's not clear why Falcarius switched from eating meat to eating plants, especially since they were adapted to be successful meat-eating theropods. One potential reason, though, is that Falcarius lived around the time of the first flowering plants in the fossil records, so maybe it just found those tastier. Therizinosaurs evolved from a raptor-like group of dinosaurs called Maniraptora. So Falcarius seems to be proof that therizinosaurs evolved from these raptor-like dinosaurs, though not directly from, say, Velociraptor, but instead from a common ancestor between it and Velociraptor that is not yet known. In the 1990s, Kirkland found the first therizinosaur in North America, Nothronicus, which was younger than the oldest therizinosaurs from Asia that had been found. So originally paleontologists thought that therizinosaurs started in Asia and migrated on a land bridge between Alaska and Siberia to get to North America. But Falcarius is 125 million years old as the oldest known Asian therizinosaur, Bapiosaurus, and it's also more primitive. There's also some evidence that this land bridge didn't exist 125 million years ago. So since Falcarius is the most primitive dinosaur in the therizinosaur group, this shows that they probably used to live all over the northern hemisphere. They actually may have originated in North America, then gone to Europe and Asia. Most likely they migrated via Europe, and some paleontologists think that someday we might find a therizinosaur in England. Falcarius was an in-between therizinosaur. It had a long neck, a small head, and teeth for eating plants, but it also had a long tail, a propubic pelvis, and long legs and feet with one toe on each foot that didn't touch the ground like other theropods. Again, it was one of the earliest theropods to eat plants, and scientists know that it ate plants because it had a large gut. It needed a larger gut to digest tough plant matter, so that's more proof. It had a wide pelvis to accommodate this larger gut, which again, it needed to get nutrients from plants. And digesting plants is generally harder than digesting meat, because you need a bigger system to process the plants. Before Falcarius, it was very rare to see this transition between meat eaters and plant eaters. Falcarius had a long neck, so it could potentially eat leaves about 5 feet or 1.5 meters off the ground. Its teeth were good for shredding leaves, and they were similar to a modern iguana's. They had at least 16 teeth in the maxilla of the upper jaw and 28 teeth in the lower jaw. These teeth were leaf-shaped, and the maxillary teeth were finely serrated, so that, again, showed that it ate plant material. The front 5 teeth of its lower jaw were longer, straighter, and more pointed, so this may point to them being omnivores. They possibly ate small animals such as lizards, in addition to plants. In February of 2015, David K. Smith published an article called Craniocervical Myology and Functional Morphology of the Small-Headed Therizinosaurian Theropods Falcarius utaensis and Nothronicus mckinleyi. And this study reconstructed craniocervical musculature in Falcarius and Nothronicus based on tyrannosaurs, allosaurus, and some extant birds as models. Knowing this information makes it easier to understand Falcarius's feeding behavior, so it had a reduced bite force compared to carnivorous theropods. It may have eaten at a constant level or was low grazing. It probably used its arms a lot for gathering food. And it was a bipedal herbivore, possibly omnivore. Falcarius was about 12 to 13 feet, 3.7 to 4 meters long, and just over 4 feet or 1.2 meters tall. Gregory S. Paul estimated that it weighed about 220 pounds or 100 kilograms. The smallest Falcarius juvenile found was about 1.6 feet or 0.5 meters long. It had a small head and long neck and tail again, and fairly long arms. The hand claws that it had were large and slightly recurved, 4 to 5 inches or 10 to 13 centimeter long claws as well that were probably used for defense. There's not too much known about its head, other than it's small and elongated, but it did have a relatively large brain case. It also had relatively long legs, so it could easily run. Its thigh bones were longer than its shin bones, so it could run fast. This was because it was adapted for running after prey, compared to later therizinosaurids with long shin bones that probably waddled around. Falcarius had 3 weight-bearing toes in the foot. The first toe, again, didn't touch the ground. And based on relatives from China, paleontologists think Falcarius had downy feathers. If you'd like, you can see Falcarius at the Utah Museum of Natural History. So Falcarius is part of Therizinosauridae, and this group had wide hips, a pretty large brain case, and long necks. Asian Therizinosauridae had quill-like feathers. Most therizinosaurs have been found in Asia. And only one other therizinosaur has been found in North America so far, Nothronicus. For years, therizinosaurs were thought to be giant sea turtles or long-necked sauropods, and now scientists have compared them to giant sloths.
And our fun fact of the day is a little bit long today, but according to a paper in 2006 in PNAS, Steve Wang and Peter Dodson stated that 527 dinosaur genera had been described to date, and estimated that there were about 1,300 left to discover. They showed a predicted S-curve in the article, which shows us in the really steep increase part of the graph, and thus making us in the quote-unquote golden age. According to the dinosaur genera list, and we'll have a link on our blog, There are currently 1,007 well-established dinosaur genera since that article back in 2006, so 10 years ago now. Since there were 35 discovered in 2015, that matches pretty well with the PNAS prediction, and it would mean that we've found about half of the dinosaur genera, and there are roughly 1,000 left to discover. And just for fun, you can compare that to the number of obviously fictional Pokemon at 721, which we would have crossed somewhere in the last probably 6 or 7 years when there were the same number of dinosaur genera as Pokemon.
Gotta catch them all. And that wraps up this episode of I Know Dino. Thanks for listening, and if you want to check out our new and improved Patreon page, you can go to patreon.com/iknowdino. Until next time.
Thank you for listening to I Know Dino. If you have any questions or comments about dinosaurs, we'd like to hear from you at plesiosaur@iknowdino.com. And for more information on dinosaurs, go to iknowdino.com or follow us on Google, Facebook, Tumblr, or Twitter at I Know Dino.